Hello students, Saint Elizabeth School in our e-learning account mathematics class 9, unit 15, title of the unit probability. With the fourth session, we continue exercise question number 5 to 8 sums. Here we begin with the sum number 5th. Over the fifth question, an organization selected 2400 families at a random and surveyed them to determine a relation between income level and the number of vehicle of the family. There is a tabulation pattern sum given to you, very fifth question. There is a certain information regarding and according to tabulation question answers to be statistically answered. So when we see the first table, the income is when the person is having less than 7, number of per family vehicle. So in that income source is 7,000 less, then 0 vehicles are so 10, one vehicle in a family will be there, 160 families such are available, 2 family, then 25 family available, at least 0, at least above 2, that is 0 for less than 7,000 income. So on, the data is given to you 7,000 to 10,000 income source, 10,000 to 13,000, 13,000 to 16,000. Suppose a family choose to find the probability, very first condition. This is the data, and from this data your condition is given for find a probability for income about 10 to 13,000, income about 10 to 13,000 per month, and owing exactly two vehicle. In this 29 we are talking for this line we are talking for. So let's see very first probability. For very first probability we convert here earning rupees 10,000 to 30,000, we come across 29 we were having. So how to write a probability for a family earning 10,000 to 13,000 with the two vehicles. So for 10,000 to 30,000 with the two vehicles, we see here again, this is the content 29, which is your vehicle with the 10,000 to 13,000 range, and total number of families we have here, that is 2400. So divide by total number of family, which gives you 29 divided by 2400. This was the condition number 1. This was the condition number 1. Let's see condition number 2 from the first fifth question only. Earning rupees 16,000 or more per month and owing exactly one vehicle. That means here it is explaining person is having more than 60,000 income and having one vehicle. So one vehicle and more than 60,000, where the when we meet over this both the point, that is 579 is your required probability. So how we will write probability for a family earning 16,000 or more with a one vehicle is equals to number of family having 16,000 or more one vehicle divide by total number of families, that is 579 divided by 2400. When we convert means consider here the total of the 5 plus 7 plus 9, which is equals to, here we receive 12 and 9 21 is a multiple of 3, and 2 and 6 is also multiple of 3. So we can divide both the term by 3 table, 3 1 93 and 3 800 24. This way 193 upon 800 is your second probability. Therefore 193 upon 800 will be your second probability. Third condition we come across. Third condition states like earning less than 7,000 per month and does not have any vehicle. Does not have any vehicle. First condition, less than 7,000 per month. That is number is 10. That is number is 10 number of the candidate here in the family we have having the less than 7,000 earning source and no vehicles. So 10 out of 2400, which we deduct 0 both, So we receive 1 upon 240 as a probability. So we receive 1 upon 240 as a probability for the condition number 3. Let's check condition number 4. Earning rupees 13,000 to 16,000 per month means 13,000 to 16,000 and more than two vehicles. More than above two vehicle is 25 number of probability. So a family earning 13,000 16,000 more than two vehicle is 25 upon 2400. This is been deducted by the table 2 25 ones and 25 eights 240 to 2400. When we divide by 25 we receive 96. So 2400 is divided by 25, then we receive 96. So when we deduct both the term with the 25, 1 upon 96 will be your probability for the fourth condition. Let's check another condition number 5th. Owing not more than one vehicle, just not more than one vehicle, which means what? Owing not more than one vehicle means income source is not given. You have given 1 and 2. Not more than 1 means 1 also we have to take and 0. So less than 1 and 0, what are included in these two box, that all together when we sum up will give you 2062. And total number of family we have 2400. So both can be deducted by 2's table, 4 table when we divide 600, and at a numerator decimal will come 515.4. We deduct by 2 only. We deduct by 2 only. That is 1031 upon 1200. When we divide both the term by 2 table, then numerator is 1031 divided by 1200. So 1031 divided by 1200 will be your second probability. Probability for the point fifth. Let's check the example number sixth now. Over the sixth example, when we move, there is a table again that you have to refer from the chapter 14, table 14.7. Question is given, certain marks given and number of students are given. So there were total number of students is 90. Probability 1. Find the probability that a student is less than 20% in mathematics test. Less than 20%. So when we talk about less than, we do not include above more than 20. This, so above this we what we have, that we have to take, that is 7 upon 900. So when we get a student less than 20%, is number of student is 7 upon 90 itself for the first condition. When we talk about second condition, over the second condition we see, find the probability that student obtain a mark above 60 mark or above 60 mark. And when you see above 60 mark, 60 and above 60, then you have to take both 15 plus 8, which equals to 23 divided by 90 is your part of the solution. Third condition was been second condition was very clear, 60 and above 60 marks. This was the question 6.2. Now we see question 7. What is the question 7 to be explained? To know the opinion of the students about the subject statistics, survey is given of 200 students. So number of students is 200 here again. Opinion, liking and disliking. Out of 200, 135 like certain thing conducted of the data. Subject statistic, those who like, there are 135 students, and those who don't like, there were 65 students. We have to find the probability of the student randomly. Both condition we have to find. We talk about first condition, liking over statistics. Probability is equals to number of students who like statistics divided by total number of students. Number of students who like statistics 135 divided by 200. When we divide both the condition by 5, that is 27 divided by 40 will be your final solution for 27 upon 40 will be your liking statistic probability. Let's check another point, that is disliking the statistics. Those who don't like statistics is the probability is equals to number of statistics do not like, number of students who do not like statistics divided by total number of students, that is 65 divided by 200, which equals to, when we deduct both by the 5 table again, so 5 13s upon 5 40s, so 13 upon 40 will be your final probability for the second point, disliking over the statistics. Let's see example exercise sum number 8 now, or referring to question 2 from exercise 14.2. Again you have to take the data reference of the 14. Here already few data have been noted in the tabulation. From the empirical probability that engineer lives, that is a norm, we are finding that empirical probability here only. What is the first condition? Less than 7 kilometer from the place of work. Means question is asking here number of engineer living and far distance are given. Survey was done. How many engineers are total here available? There will be 40 engineers. 3, 3, 6, 3, 9 and 1 10. 10 into 4, that is 40 is equals to number of engineer. Total number of engineer total. And different data for kilometer we have. Very first condition, less than 7 kilometer from the place of work their residence is there. An engineer who lives less than 7 kilometer, probability is equals to divide by total number of engineers. For less than 7, which are less than 7, let's check it out. For less than 7, 5 3 3 5 6 2 6 3 2. So there were number of the 9 engineers out of total number we have 40. So probability answer for the first point, the number who lives less than 7 kilometer far from the place of work will be 9 upon 40. That is your probability first condition for the 8th question. Let's check second question, second probability. Condition 2 is here talking about children more or equal to 7. Now you have already find less than 7. You read now more or equal to 7. That means from 7 you minus total, from total you remove the less than 7, then ultimately 31 will be more than or equal to 7. We have total number of candidate is 40, and out of 47, 9 candidate having the less than 7 kilometer far away from the place of work. That means number of engineer lives more than 7 kilometer divided by total number of engineer, that is 31 upon 40. This way you can consider the example number 8. After considering example number 8, let's check the second condition, example 8, third condition and the last condition. While what is the empirical probability that engineer lives within the half kilometer from the place of work? So half kilometer is not given here in the data. So zero number of the probability we receive. From total probability we have 40. When we divide 0 by 40 we'll receive 0 only. This was the, an engineer lives half kilometer is 0, divided by total number of engineer is 40. So we receive 40 as a part of the solution. These were the exercise question 5 to example question 8. We will see further question in our next session. Till that, practice all the video, revise all the sum, and keep watching our video over the given link. Thank you.